Good afternoon, students. Can you hear me? Okay. Thank you. Thank you, Meghna. Thank you, Ron. Okay. So, good afternoon to you. Yesterday, there was a little bit of explanation issue regarding your first option, that is insert at start. So, I said that I'll bring it in more animated manner so that each and every student will understand the concept completely. So, as you are seeing it on your screen, we are taking cases where there are no nodes. That is, H is meant for your head node, and temp one is meant for your tail node. Or head H is meant for the first node, and temp one is meant for your last node in the doubly linked list. And temp is a temporary node, right? So that is the premise which we are going to follow throughout this understanding of doubly linked list or double linked list. Okay, so let's start the case one. In the case one, h is equal to null, right? This h value is equal to null. So since h equal to null, this is true, right? This is true. It won't go to the else block. Since this is true, it's going to call the create function. Since it is going to call the create function, this function gets called. This function gets called. So when this function gets called, in this function, the local variable is data, right? And then what we are doing is we are creating a temporary variable. That is, we are assigning the memory location of that much bytes and storing in a pointer called as temp. Storing in a pointer called as temp. So this temp, assume that the base value is 2000. So in temp, we have the base value as 2000, right? Then temp of previous, we are equating it to null. Temp of previous, we are equating it to null. So also temp of next, we are equating it to null. So temp of next is also null. Then we are giving a prompt on the screen that enter the value to the node, and using the scanf statement, in this data, we are storing the value. In this data, we are storing the value. So temp of n, right? Temp of n is equal to data. So that data, we are storing it as 20. And the count, that is the number of number of nodes count is going to increment, right? So this is as far as the first case is concerned. When we started with what? We started with this state that h is equal to null, and then because h is equal to null, we call the create function, and in the create function, starting from here, we started building this particular node. So there's only one node. There's only one node. So since it's only one node, this h is also here, and temp1 is also here. Both are here, right? So that is what h is equal to temp. H is equal to temp. So h is equal to 2000 and temp1 is equal to h. So we have h and temp1 both are the pointers which are pointing to the same base address of 2000, right? Now let's consider the case 2. Now what the case 2? Assume that this one node is already there, right? So since it's already there, h value is 2000. H value is 2000. I'm considering the case 2, those who are joined late. I'm considering the case 2 where already we have a single node. Since there is a single node, the previous is null, the next is also null, right? And H we are always keeping as the first node or the head node, and temp1 we are always keeping it at the last node, right? Since it is only node, therefore H and temp are both having the base value as 2000, right? Now the case 2. What the case 2? We already have one node, so H equal to null. What is H value? H value is 2000. H equal to null is false. Since it is false, it's not going to come in this if block. It's going to come go to the else block. Again, in the else block, we are calling this create function. In the else block, we are calling this create function. So in this create function, the temp pointer is storing some base address. Assume that base address is 2000 where there is a structure, right? So the temp of previous is equal to null. Temp of next is equal to null, right? Enter a value to the node and that value, assume that we have added that value as 10, right? So the create function, this particular statement has happened and this much job has been done. So previous is null, next is null, name of this particular node is temp, which is storing the base address as 1000. So far we have not linked it because we have just completed the call to the create method and only this particular statement is over. Now temp of next is equal to h. This is the temp and this is the next. Presently it is null. This we have to make it h. What is in h? 2000. So this null has to get replaced with the 2000 value, right? So now this particular node, what are we handling it? Insert at beginning. Insert at beginning we are handling. So whenever we are adding a node, to the chain, this node has become the first node, right? Which is the first. Now still it is a half job done. So only one step has been done. Temp of next is equal to h has happened, right? Temp of next is equal to h. Now h of previous is equal to temp. What is in temp? 1000. So this null value will change to 1000. So this is going to look here. This is going to start looking over here. Okay. Now head, as I said, h is always keeping is located at the very first node, right? Now, because we are called the insert at the beginning and the previous state was what? We are already having a node and we have added a new node, but that new node has become the first node. So this h has to start, presently h is storing 2000. This h should store 1000. How? H is equal to temp. What is in temp? 1000. What's the h presently? 2000. So after this particular statement, this h is going to go and start having the value as 1000. Are you clear? Uh, Saurabh is saying temp is created and insert is different, sir. Temp in create and insert is different. No, it is same. Temp in create and insert at is same. Where are you? Where is the confusion? In the first code or in the second code? So temp is a local. No, it's not local variable. Temp is not local variable. It is global. Okay, let me take you back. See here. H, temp, temp1, temp2, temp4. They are all global variables. Okay, not an issue. You don't have to say sorry. See, there is no question of sorry, students, right? You asked a doubt, absolutely with a fearless mind. Okay, it's my duty to look into it. No need of saying sorry. Have a clarification. Have a clarification. Just never feel guilty that you are asked a wrong question. No. Yes. Okay, Saurabh. Good. Right. Great. So, uh, yeah. So this point yesterday, because I could not animate it, I simply explained in a theoretical manner. But any other student, any student who has not understood both the aspects, case one when there are no notes and case two when there are notes. We are presently considering when there is one node, but not it may be a already existing linked list of 100 nodes, right? Just for the simplicity, we have considered both the cases. Any student who has not understood any of this part, please come to the chat window and I'll be more than willing to explain you again. Any student who has not understood, feel free to come to the chat window. Okay, fine. So the next part, in insert at end, right? Insert at end. So again, first, if this is a state, if this is state, that H is null, H is null, right? H is a global variable, but initially initialized to null, right? That doesn't mean that the memory is there. H is storing the null value. So this is true. When this is true, it's going to call the create function. So this is it gives a call to the create function. When it gives a call to the create function, now insert at end, right? So in the create function, that temporary pointer, the temporary pointer, assume that the base address 1000 is getting stored. The temp of previous, we have made it null. Temp of next, we have made it null. Then through the prompt, we are asking the value, and in the scanf statement, we are giving the value as 10, right? So this is the case one. Now h is equal to temp. Now this particular h value, the head pointer, the h pointer is always storing at the is always pointing at the first node, right? So presently h is equal to h is also storing 1000. Then temp1 is equal to h, right? So at the present, temp, h and temp1 are all storing the same base address 1000. When we started with the premise, what? When h was equal to null, means there are absolutely no nodes in my doubly linked list. And there are absolutely no node in my doubly linked list. So whichever node I'm adding is the first node, right? H is storing the base address of the first node. Because there is only one node, temp1 should be having the base address of the last node. But because there is only one node, H and temp are both pointing at the same base address, that is 1000, right? Now, case 2. What is the case 2? I'm wanting to add at the end. Okay. So let's make an assumption that this is there. What? This is the first node. This is the second node. This is the first node. This is the second node. Because this is the first node, its previous is null. The data is 10. And the next is 2000. It's pointing over here. Now this is the second node. This is the second node or the last node. So Therefore, it is temp1. The previous is pointing to the base address of the first node. Data is 20 and the next is null, right? So there are only two nodes as far as the linked list is concerned. There are two nodes as far as linked list is concerned, right? So H, I have not shown it here, but H is here. H equal to null is false. H equal to null is false. So what are going to happen? The case 2. That is, we are going to come to the else block. In the else block, first there is a call to the create function. So the call comes to the create function, and in the create function, what we do? We create a temp variable, right? Now the temp variable, the previous is null, the next is null. We are giving a prompt, enter the value of the node. The user has given the value as 30, right? And the temp value is 3000, right? The temp value is 3000. So this call is over and it has constructed an isolated node. You can see that is not linked to this, nor this is linked to this, right? So this step is over. Next step, temp1 of next is equal to temp. This is temp1, right? Of next is equal to temp. What is stored in temp? 3000. So when this statement happens, temp1 of next, we get 3000, right? We get 3000 here. So this 3000 is pointing over here. This 3000 has started pointing here. Now temp of previous, what was previously null here? What was previously null here? Temp of previous is equal to temp1. What is in temp1? 2000, right? So this step, this 2000 has got stored here, right? Means in temp of previous, we have got the base address of temp1, which happens to be 2000. Step 3. Now, as always, temp1 is pointing to the last node, so we have to advance it from here. We have to advance it from here and bring it here. So temp1 is equal to, right? So temp1 is always pointing to the last node, right? So are you clear about each of the statements? Anyone has any doubt, please come to the chat window. At the same time, think the difference between the insert at beginning and insert at end. Students, any doubt? Okay, no doubt. Fine. Now the delete method. Now in the delete method, just go through the code. It's a longish code. Just go through the code up to here. I'll come back. Okay. Now let's assume that these are the three nodes. Here are the three nodes. And let's go statement by statement in the entire delete function. And that too. So when at a particular position, right, the user is expected to give a particular position, the node which he or she wants to delete. Okay. So we have a local variable I initialized to 1 and one more local variable POS standing for position, right? First position, second position, third position. Which position node you would like to delete. So that's the purpose of this second local integer variable POS. Enter the position to be deleted. Enter the position to be deleted. To start with, temp2 is equal to h. So a pointer because we cannot manipulate h and move it to the some other location because h, as I said, that h should continuously point to the head node or the first node, and temp1 should continuously remain at the last node. Okay, so this we are sorry. So we are making use of the other pointers called as temp2. Now we know very well that there are three nodes. Possibility one. Possibility one. We are asking very gently that question, right? So suppose you give some negative value or zero value. Delete the node at -3 or delete the node at 0, right? So in this if position POS, we are taking it over here, 0 or negative sign, then we are saying position out of range to delete, right? Other way around, we know one position, two position, three position. Suppose here uses that say 7, right? And this count in the previous code, you are always continuously seen in the create function. The moment we are creating means what? We are creating one additional node, right? So 7, the actually count is 3 and 7 greater than 3, true. So in these two cases, we are coming in this if block and giving a prompt to the user that you are giving me a range which is not well within the number of nodes which are there in my linked list. And we are returning also, returning the main pointer, returning the main pointer. That's the case one. That's the case one. Case two, there are no nodes, right? Honestly, we should have selected the option one, inserted the nodes, at least 5-6 nodes, and then come to the delete. But we can't. We have to cater for this. There were no nodes, and still we have called for this delete function, right? So when there are no nodes, obviously h is going to be null. Obviously h is going to be null, right? So when h is null, empty list no elements to delete. And again we are running, right? So case 1, incorrect position. Case 2, call the delete function when there are no nodes in the linked list, right? Answer for this is no. Answer for this is no. So obviously it's going to come to the else block. Else connected with A, right? Else block. In the else block, assume that here he has given the position as 2. So PO is how much? 2. This is position 1, position 2. So he is interested in deleting this particular node. He is interested in deleting this particular node. So temp2 is pointing here. Presently, H and temp2 are here, and the user is interested in the position 2 node to be deleted. What is I? We are initialized to 1. What is POS? We are given as 2. So 1 is greater than less than 2. True. 1 is less than 2. True. Temp2 is equal to temp2 of next. So temp2 which was standing here is now going to come here. So here it is temp2, right? Not animated. So, but now you can well imagine. I've trained you enough to stretch your imaginations. temp2 which was here, temp2 is equal to temp2 of next. So temp2 has come here. I plus plus. I value is 1, so I have become 2. Right? 2 less than 2, false. 2 less than 2, false. So this while block is over. So we are continuing in the else block. This else block is beginning here and the else block is finishing here. Right? So we come here, I equal to 1. No, because I value has already become 2. So it won't come in this particular if block. It won't come in this if block. Right? Now, if temp2 of next equal to none, where is temp2 here? What is temp2 of next? 3000. Equal to null is false. So this if block is also not valid. So it's not going to enter the if block. Not going to enter the if block. Right? Now, where will it go? Statement temp2 of next of previous. Please try to understand, all of you. Temp2 is here. Temp2 of next is what? 3000. Right? It comes to 3000. At 3000 previous, what is 3000 previous? Is this. 3000 previous is this. So temp2 of next of previous is equal to what? Temp2 of previous. Temp2 is here. What is temp2 of previous? 1000. So this is going to get replaced with what? 1000. So it has come here. Right? Are you with me? Okay. Okay, Bhavana. Sorry. My voice must have gone low. Okay. Bhavana, should I explain again? As the voice was not clear. Feel free. Yeah. Right. Right. Sure. Sure. Why, please? Definitely. I, I was not looking at the chat window. You should have sounded me. The voice is not there. Anyway, I'll repeat again. See, the two cases which we are considering. Initially, 1, 2, 3 positions are there. The user has given a negative position, right? It gets caught here. Position -1 is less than 1, and there is a or. Because there is a or, this if condition is true, and we give a prompt position out of range and return back to the main function. Case 2, we know position 1, position 2, and position 3. The user has given 7, right? Now this POS is 7. 7 is greater than count. Count is how much? 3. So this condition is true. And because there is or, so again it comes over here and position out of range will be displayed and returned back to main. Okay, that is case 1. What is case 2? The case 2 is that there are no nodes here, right? There are no nodes in the linked list, and yet the user has asked for deleting a node. So when there are no nodes, h is equal to null. So this condition is true. So since h is equal to null, empty list, no elements to delete, right? There are absolutely no nodes, and you are asking the user, asking our program to delete a node, right? So if the situation is like this, right? There are 3 nodes. So and the user has given 2. So the POS value is 2, right? So this is not satisfied. This is not satisfied. It's not greater than 3, and it's not neither it is less than 1. So this is not satisfied. H was pointing here. So H equal to null is not true. So we come to the else block. In the else block, we have the while loop. In the while loop, the I value initialized to 1. So 1 and post value is 2, 1 less than 2, true. So temp2 which is here as per this particular statement, temp2 is equal to h. So temp2 and h initially they were standing here. So temp2 is equal to temp2 of next. So temp2 will go from take one step forward. From here it has started standing here now, right? I plus plus. I plus plus is what? I is 1. So 1 plus plus is 2. 2 less than 2, false. So this while loop is over. When the while loop is over, one of the condition I equal to 1, we have to test. I value is already 2. So this condition is not true. This condition is not true. So it comes to the end. End of what? The else block. Now, if temp2 of next is equal to null, where is temp2 here? What is temp2 of next? 3000, right? 3000 equal to null, false, right? False. So since it is false, what is going to happen? What is going to happen? It won't enter the if block. It's not going to enter the if block, right? Now, I not equal to 1. So temp2 of previous of next. Temp2 of previous. Temp2 is here. Temp2 of previous of next. What is temp2 of previous? It comes to 3000. At 3000, what is? I missed this step. So temp2 of next of previous. Temp2 of next of previous, that is this, equal to temp2 of previous. Temp2 of next of previous is equal to temp2 of previous. What is temp2 of previous? 1000. And temp2 of next of previous is 2000. So this 2000 is going to get replaced with 1000. Yes. So when it is getting replaced with 1000, then what we are doing? We are freeing temp2. So this particular node, which is over here, gets freed. When it is getting freed, the linked list is intact. How is it intact? First node, previous is null, data is 10, next is 2000, right? Now, I, so this particular 2000 has to get connected with 3000. Yes, right? So before it comes to this free, I not equal to 1, that is true, that is 2 not equal to 1 is true. So temp2 of previous, what is 1000, of next is equal to temp2 of next, that is 3000. So this particular statement comes into play. This statement comes into play, and this 2000 is going to get replaced with 3000, right? And then since I equal to 1 is false, so it won't go over here, node deleted, and then we free this. Students, am I clear? Anybody who has not understood, please come to a chat window. I am always with who has not understood. In first if, just count is enough. No, sir. The first if. Uh, this one you mean? How count is enough? Suppose the user has given some negative value, then the user has given negative value, then this is false, no? How do you want to keep the count and use I not equal to 1 condition? Yeah, I'll come to that. I got your point, Raghavendra. I'll come to your point. Keep it holding because suppose the window goes bigger Raghavendra, hold the point. Let me was finish with Sahitya. Sahitya, you take count if the user has given the negative position. So it goes, or the user has given zero or negative. So that condition, I am handling it. I not equal to one part. Yeah, I'll explain. Now I am coming to you. Raghav Vendra also has got the same issue, and Harihara also got the same issue. We can just say position is greater than or equal to count. Position greater than or equal to count. Position greater than or equal to count. Okay, I think you may try. May work. May work. Looks like. But since I given probably it must makes a meaning. Suppose I give negative value. Negative value cannot be greater than or equal to the count. If the count is 0, that time also it is false. How will it come? Suppose I give the value as 0. Who is this count greater than or equal to 0? Right here. If I given 0 and the count is say 0 greater than or equal to 0, false, no? Initially, suppose there are no nodes. No nodes will come in H. No nodes will come in H. There are 3 nodes and you are given 0. 0 node. So 0 greater than or equal to 3. Uh, how will it come to this if condition? It won't come. Right. Okay. Now let's come to the Saitya, Raghavendra, Harihara, and others. Right. Actually, it was my explanation from here. Straight away, I jumped to here. So I take the blame to me. Probably I have confused you. So let me come again. There are 3 nodes. There are 3 nodes. M2 is here. Based on this statement, M2 is here. H is here. Right. M2 is here. H is here. So this is false. This is false. It has come to the else block. This else block has started here and the else block has terminated here. Okay. In the else block, while I value initialized to 1, position is 2. 1 less than 2. True. Temp2 is equal to temp2 of next. Temp2 was here. Temp2 of 2 has come here. Raghavendra, Harihara, are you with me so far? Temp2 has come here. Raghavendra, Harihara, both of you. I am dealing your case. Right. Okay. Good. Now I becomes 2. 2 less than 2. False. So we come out of the while loop. Right? Where is temp2 standing? Here. Temp2 is standing here. Now I equal to 1. False. Because I value is already 2. 2 equal to 1. False. So it won't enter this if condition. Right? If temp2 of next is equal to none. If temp2 of next so this won't happen. So we are now out of the else block. Now we are coming to after coming out of the else block. Temp2 of next. Temp2 is standing here. Temp2 of next is 3000, not equal to none. So this if condition is false. Now this statement. Temp2 is standing here. Temp2 of next of previous. Temp2 of next is the 3000. 3000 comes here. Previous 2000. Right? Presently. So temp2 of next of previous, that is this, is equal to temp2 of previous. Temp2 is here. What is previous? 1000. So this 2000 is going to get replaced with 1000. So this particular node has started pointing here. Presently state it was pointing here because I am planning to delete this particular node. So I said temp2 of next of previous is equal to temp2 of previous, which is 1000. So this 2000 gets replaced with 2000. So far, are we in sync? Hariyara, Raghavendra. Right. Now, what is the value of I? Hariyara, I value Q not equal to 1, true, true, right? So, temp2 is still standing here. Temp2 of previous. What is temp2 of previous? 1000. Temp2 of previous of next is this equal to what? Temp2 of next. What is temp2 of next? 3000. So this 2000 is going to get replaced with 3000. Are you with me? Hariyara, Raghavendra. Right. Thank you. Now, I equal to 1 false. We don't enter here and simply say node deleted and free temp2. Now this temp2 we are freeing it. Anybody any other doubt? So other cases you can please look into. Other cases please look into when I will becomes 1. When will it enter here? All these cases you look into, and I'm anyhow sharing the code with you. Anyhow sharing the code with you, and you can try all the combinations. All the combinations. Right. So I assume that the delete code is well received by you, all of you. So this I have already finished yesterday. So I'll update. Right? Update. Now update means what? Suppose the 2, 10, 20, 30 is there. Now that for by mistake, I have given the data at the second node, let's say 20. But I want to make it 200. Means what? I don't want to insert a node, nor I want to delete a node, but I want to change the value at that node. I want to change the value at that node, right? So that is what is update. So that's the job. So we have to actually, there are two things here. We are searching. If that particular value is found, that value we are modifying it to the new value. That value we are modifying it to the new value. Are you getting me? Right. So with that background, this is the update. Right. In the update, enter the node to be updated. First prompt we are giving. Enter the node to be updated as the prompt 1. Storing in data. Right. Enter the node data to be updated. So first, this is one meant for searching it. Right. That node should be there. Then only I can update, isn't it? Then I'm asking enter the new data. So suppose you are wanting to change 20 with 200. So what is the search criteria? And once it is found, with what value I should replace it? So for that purpose, this data and data 1. So data 1 is the existing value. Data is the existing value and data 1 is the new updation value. Right? Now we are taking the temp2 is equal to h, right? Starting point. Is temp2 equal to null? We are giving the list is empty. If it is false, means there are certain nodes. There are certain nodes. Now assume that we have a node, only a single node, whose previous is null. So this is a starting null, starting node, and the next value is something, right? So the user has given data, this data as 30, and this data one as 300, say, right? So while temp2 not equal to null, answer is true. Temp2 not equal to null, answer is true, because temp2 presently is having 1000. temp2 of n, what is n? 30. Now if this happens to be 30, it is matching. It's matching. So temp2 of n is equal to data 1. What data 1 value we have given? 300, right? So we modify this 30 with 300. Modify this 30 with 300. Are you getting my point? Anybody who has not understood? Simple. I don't think there should be any issue over here, right? We modify that, and then we are calling the traverse beginning method just to display and confirm that has the modification happened or no. Has the modification happened or no? That's the point. Okay. Now coming to the sort method. Coming to the sort method. It's a bit complicated method. Uh, so let us consider something like this. There are three nodes. Node 1, node 2, node 3. Node 1, first node, right? Why first node? The previous is null. How is the last node? The next is null. How is the middle node? This is previous is pointing here and the next is pointing here, right? So the next is 2000. The previous of this is 2000. The next is null. Okay. So this is my node 1, this is my node 2, and this is my node 3. Obviously 30, 10, 20 is not in a sorted manner. It's not in a sorted manner. So we want to write a code in such a manner that we would like to sort the nodes. We'd like to sort the nodes. Okay, right. So we call the sort method. We call the sort method. Now temp2 is standing here. Temp2 is standing here. Temp2 of h. Temp2 is equal to h. And temp4 also h. Temp4 also h. So h, temp2, temp4 all are starting here. Right? This is the first node, this is the second node, and this is the last node. Okay. Now temp2 equal to null, false, right? Because there are temp2 is having what? temp2 is having 1000. So it won't go into this if criteria. Now the for loops, loop within loop, for temp2 is equal to h. So temp2 is here, right? temp2 not equal to null, true. temp2 is 2000 not equal to null, true. We enter the outer for loop. Now temp4 equal to temp2 of next. temp4 is equal to temp2 of next, right? So temp4, which was standing here, it becomes temp2 of next. So temp4 comes here. I hope you are with me. temp4 comes here. temp4 not equal to null, true, because temp4 is 2000. It enters the second for loop. If temp2 of n, what is temp2 of n? 30. Greater than temp4 of n. temp4 of n is how much? 10. True. So this is a swap logic. This is swap logic. So 10 has come here and 30 has gone here. 10 has come here and 30 has gone here. We are done the swapping, right? We are in the inner for loop. Now it comes here. temp4 is equal to temp4 of next. temp4 was standing here. temp4 of next comes here, right? Now, what is temp2 is here and temp4 is here. But this has become now 10, mind it. This has become 10. So when it comes here, temp2 of next, temp2 of n. What is temp2 of n now? 10. Greater than temp4 of n, which is 20. False. So Again, temp4 is equal to temp4 of next. Temp4 was here, temp4 of next is null, right? The condition becomes false. The condition becomes false. So it's going to come out of the inner for loop, goes to the outer for loop. Temp2, which was standing here, becomes temp2 of next. So temp2 has come here. What is here? What is this value presently? No. M2 has come here. What the value of n here? 30 or 10. The swapping has happened. 10 has come here, 30 has come here. Okay? Yes, Atal. So this is 30 and this continues to remain 20. Okay? So again, M2 is equal to M2 of next. M2 has come here. We are entering the inner for loop. We are entering the inner for loop. M4. M4 is equal to temp2 of next. Temp2 is here. Temp2 of next is what? 3000. So temp4 is standing here. Right? Temp4 not equal to null. True. What is temp2 of n? 30. What is temp4 of n? 20. 30 is greater than 20. So swapping logic. Right? So 20 comes here, 30 goes here. Right? Temp4 is equal to temp4 of next. Temp4 is standing here. What is temp4 of next? Null. Right? Null not equal to null. False. So we are out of inner for loop. Where is temp2? Temp2 is here. Temp2 is equal to temp2 of next. So temp2 has come here. Temp2 has come here. Right? Temp2 not equal to null. True. We are entering the for loop. Temp4 is equal to temp2 of next. What is temp2 of next? Null. Right? Temp2 not equal to null. False. It comes out. Temp2 is equal to temp2 of next. What is temp2 of next? Null. Null not equal to null. False. We are out of this for loop. क्लास में हूँ okay, so this is the sorting logic. Yes or no? Anybody who has not understood? Loop within loop. Anybody who has not understood? Yes. Sir, why did we declare ij? Where ij? I see. Ah, okay. You're right. We don't require. Maybe my copy paste. Generally, whenever we deal with the for loops, I is the outer loop, j is the inner loop. Yeah, not required. You are right, Meghana. Who is this? Yeah, Meghana. Not required. You can remove. Can we write this while loop? Which one you are talking? The two for loops. Yeah, you can take the while loop also. But see what happens when you take the for while loop, when you take two while loop, that is a while loop within a while loop, then outside the while loop, you have to declare initial values, right? Therefore, the for loop takes care of that. That's the reason why I have reduces the code actually. The number of lines of code is reduced. Nothing more than that. Yeah, Durga Prakash. Using selection sort technique. Yeah. We are doing selection sort. Yes, Durga Prakash. We are doing the selection sort on. But you can replace that with a bubble sort, which technically is much better than selection sort. Sorting should be understood. Okay, the technique of sorting we can always modify, but the sorting has to happen. All right. So let me see. In the first for loop, the terminating condition must be temp of next not equal to null. Temp or temp 2. In the first for loop, we are taking temp 2. Yeah. If you take temp 2 of next not equal to null, yeah, we can reduce one iteration. Yeah, we can reduce one iteration of bringing it there. Could be. Yeah, we may be able to reduce one iteration. Now, this is that code. And compiling the code and then running it. So one, or let's go the wrong way. Now we want to say delete, which is 4. We know that pretty sure that there are no nodes. So we give 4, though we know that there are no nodes. So enter position, say second position, right? So there are no nodes and we are giving that. So we go to the display. What is display from beginning? 5. We know pretty sure. So the list is empty, nothing to display. So let's go to 1. So what is choice 1? Insert at the beginning. Asking value. So 10. Right? Again, choice 1. Node 5. So what has happened? Initially, the first node was 10, and then again we are asked for insert in the beginning. Right? So let's see whether it has inserted at the beginning. First node was 10, second node was 5. So if I ask for the display 5, so we are getting 510. Now option 3, insert option 2, insert at end. Let's give 2 options. And suppose the node is say 20. Right? Again, let's display 5. So 5, 10, 20. Okay. Now again enter the choice. The deletion was choice 4. Enter the position to be deleted. Say 2. Node deleted. Again, it's 5. So node 2 got deleted. Node 2 got deleted. So let's say go 7. Enter the value to be searched. Let's go the wrong way. We know that 10 is deleted. Say 10. So error 10 not found. Right? Choice 7 again. Let's search for 20. Data found in position number 2. Right? What is 8? 8 is list of elements from beginning. Let's go for 9. Enter to be updated. Now let's update this 5 with 50. So enter the data to be updated. I'll say 5. New data 50. So 50 and 20. For the last choice 10. And we are out. Okay. So this code, students, I'm sharing with you. I'm going to share with you, and Shankar sir will circulate it amongst you, right? Shankar sir will circulate this among you. So this is how uh, we can work it out. This is how we can work it out. Now coming to the circular link list. Coming to circular link list. Now circular link list, I would like to cover it in the next class, right? Because let's start fresh. Let's not mix up the double linked list with the single linked list and confuse ourselves and everybody. Okay. So Shankar sir will start the quiz. Please attempt the quiz, and then that will be the end of today's session. So in tomorrow, that is a Friday class. Again, I am going to take that Friday class. Tomorrow, I'll be completing the circular link list, and if time permits, let's see what we can do without wasting time. So once again, as I have announced in yesterday, uh, we 17 programs in all will be there for your unit 1 and 200 quiz questions. So Shankar sir will very shortly share all these 200 questions with the answers. MCQ of 200 with the answers. So all of you, please go through it, understand the logic, understand why the question is right or wrong, which is the choice. Out of these 200 questions, any 30 will come. Any 30 will come. Out of 17 programs, any two programs will come to you. Any two programs, right? Now, what is the spread of these 17 programs? Single link list. The common factor is insert and display. In single link list, there are 5 questions, but the common factor is insert and display, right? The question which you may get, in addition to insert and display, insert at the beginning and insert at the end. The second question could be inserts anywhere in the linked list, right? Search in the linked list, reverse the linked list, concatenate two linked lists, sort the linked list, right? So in single linked list, all this is spread. Same is applicable for double linked list. Same is applicable for double linked list, right? Sorting, searching, insert in the beginning, insert at the end, insert anywhere, and maybe update in the double linked list. Third question, queues, right? Queues using arrays, queues using linked list. Stack, stack using arrays, stack using linked list. Next question, infix to postfix, infix to postfix. Next question, skip list. Now, any student who gets the skip list, he is going to get only one question because it's a longish code. It's a longish code. Any student who is going to get skip list, only one question. And time given is 1 hour 45 minutes. And 15 minutes, 30 questions you have to answer. And the last question is going to be your hash table. But don't go by all these rumors. Don't go by all these rumors. It cannot get cancelled. At the most, it can get postponed, right? But whether it happens, scheduled date is 1st to 7th. Scheduled date is 1st to 7th. So don't go by any rumors till the time in writing we get it from JNTU. So as of today, it is there. As of today, it is there. Unless it comes in writing from JNTU and then it is posted on the website. So as of now, it is there. Yeah, so many students are in the chat window. What is your query? Students, what is your query? Which clarity, Shankar? Yeah, Shankar, which clarity? I'm telling you, you have to do these 17 questions and 200 MCQs. Yeah, I'm sharing you. I'm sharing all the code about 2-1 or 1-2 exams. What is 2-1 and 1-2 exam? Semester 2, Unit 1. I don't know what you are hearing and who is telling what. What I know from the college side is between 1 to 7, your unit test 1 will be conducted. Right? There is no confusion in my mind. What was told in the meeting? What was told to the CRs in the meeting? It may be postponed or it has been postponed. That unit tests are postponed. Confirmed. Hold the line. Anyway, let Shankar sir start the quiz, and I am contacting the college, and if I get a confirmed information, I'll share with you. Is that okay? Okay. Shankar, please start the quiz.
Yeah, okay, sir. Yeah, hello guys. The quiz is started. Please go to the quiz.
1 to 7. Between 1 to 7, please.
Yeah, hello. Hello everyone. Is my audio is audible to everyone? Yeah, thank you, Surya. Just now
Yes,
started.
students, it is confirmed that between 1 to 7, you won't have the
Please go
unit
through.
1 as far as data structure is concerned. Have you heard me, students? As far as data structure is concerned, between 1 to 7, it is not there. Confirm. Hello? Right. Shankar sir, are you there? Karan Tej, between 1 to 7, your data structure test will not be conducted. It has been postponed. Yes, Meghna, you are right. Between 1 to 7, it is not there. You can start the quiz. Started. Okay.
Yesterday we conducted some quiz, right, regarding a double linked list, right? In that one, three questions are from circular linked list. So even though circular linked list, most of them are attempted correctly. So yesterday was 354 logins are there. In that one, 146 total 354. 146 students have got 100 out of 100, and remaining 150 as attempted, but they are graded as less than 100. And today, whatever the quiz we kept, more questions, means 4 to 5 questions from circular English. Okay. Meanwhile, just I want to give that previous quiz questions with an answers. So first question I just want to ask in that one. So a linear collection of data elements where the linear node is given by mean of pointer is called primitive list or linked list, non-node list. Node list, right? In a node, what we'll do, we'll create one data within a pointer. Pointer is used for referring to the address, right? So which one answer? The node list. The second question I gave you is the variant of linked list in which last node of the list pointing to the first node of the list is called cycling list. How? We create some one linked list like this one linked list, node 1, right? One more node 2 is there, right? One more is node 3. We create node 3, right? This is pointing to you, this one. This node 2 is pointing to this one, X node. Suppose this is address 1, 2, this is 3. Normal double link, what will be there? Here null will be there. Here also null will be there. In single English, whatever the address is there, we are going to keeping over here. Means looping of this one. So that only we are asking that one. In this question, linked list, the last node of the list pointer of the first node. Last node is pointing to first node. It is called a single, what is called circle linked list. Right? In the third one, same, a variant of linked list in which none of the node called null pointer. In double linked list, we have the null pointer at the end and beginning, right? First node and last node we have the null pointer. But if does not having a null node, it means circular linked list. Simple. So this topic is going to cover tomorrow. In circular linked list, insertion of node require modification of which how many pointers we require? 2 pointers. One is previous, one is next. Forward direction, backward direction. We require only 2 pointers. Fifth one, In double linked list, traverses can be performed. How can be traveled in a linked list? We can travel forward and backward. So we can call option B in both the direction. In sixth question, I gave you in the question. In linked list, each node contains minimum of two fields. One field is data stores, and the second field is using to hold some what we'll call a node is pointing to the next. We can call reference. We can call address. So which is the correct answer? Pointing to the node. Yes, the address is used to storing for pointing to the next node. So option A is the pointing to a node. In seventh, in worst case, the number of comparison needed such single linked list of length n given elements. Worst case means if there is an element is not found, how many are there? What is the time complexity required? N only, because we are not searching multiple times. In a length, what we'll call will go in a direction, right? Forward direction only. If you say node 1, node 2, node 3. In node 1, we'll compare with that value. If suppose we're searching some element, if it is matching or not, we'll check. If it is not matching, we'll move for next one. If not matching, we'll go for next one. So if there is matches, then it is going to print it. If there are not matches, it will go until null pointer, last node. So now how many ways we are going to answer? One, only one direction, right? So answer is n. N is number of nodes we are traversing. Yes. What about the eighth question? Linked lists are not suitable for implementation of which one? Binary search. Radical sort, insertion sort is sorting technique, different types of sorting technique. But binary search is not suitable for implementing of linked list. And this is a time composition once again. The concatenation of two lists, two single linked lists, it can perform O of one time. Which are the following variant of linked list are used? So O of one time, which one is the cyclic double linked list? The concatenation of O of one of time it is going to take. It's one time. What kind of linked list is the best answer? What is the item at a position n? Array is the best one. Array implementation of linked list is the best one. And 11th one is asymptotic time complexity to added node for the end of single linked list if the pointer initially point to the head of the list. What the asymptotic is theta of time. This will come under the next topic that Sir is going to explain you that what is in asymptotic notation, what is big O notation, small O notation, what is theta notation. But initially, if you want to pointing something in a single linked list, the time complexity is going to take theta of n. In the 12th one, same asymptotic sign time complexity of adding an element in the linked list. We take O of n, big O of n. If you want to find a linked list, time complexity required big O of n. Big O means there are a lot of different in asymptotic they have big O, small O, and theta. So you have to read this is not O of n, big O of n. And the 14th one also I gave you that asymptotic time complexity of inserting a element at the second position of linked list. It takes O of 1 because we are inserting one node in a linked list. We know that one where to insert, right? So we directly traverses second node and we are going to insert. It takes O of 1 time, whereas previous one is take O of n for searching or insert what we call finding an element, or we can call searching an element we take O of n, but if you want to insert a particular position, the time taking is O of 1. The last one is on which of the operations is performed most efficiently by double linked list then single linked list. This deleting a node whose location is given. So best performance comparing to the double linked list, single linked list, which one is the most efficient is deleting a node which whatever the location is given, this is performed more. Is it clear? If anyone have a doubt regarding this 15%, please raise in the chat box. Today I gave you 20 MCQs, which covers a double E, single, and normal English also. Please go through it. And those who have doubts in that circular English means, just uh, assuming that double linked list, it contains the first node, last node, we have the null, but when instead of keeping null, we are pointing that first node to last node, means we are forming a loop. That is called circular English. That is going to cover in the next class. You can understand very better. So if that question will come, so that is an answer for that. Exactly, the quiz is going to stop at 2:30. I gave you the 20 MCQs with a time limit of 20 minutes. Right now that out of 462, 29 students are submitted to the quiz and they graded as 100 of 100. I want to show you their names. This many are submitted to the quiz with a duration of 10 minutes. Instead of that not taking a 20 minutes of time, they completed 8 to 10 minutes and they has been graded as 100 of 100. This is Sai Snigdha. I think she lost one question. And at exactly 2:30 I'm going to stop the quiz. Before the time exists, please submit. Otherwise, your quiz is not evaluated. Okay, that's it for today class, and we'll meet you tomorrow. Thank you guys.